Okay, so this is the second lesson in dealing with scatter plots. And what we're going to talk about today is what's called a line of best fit. And if you think about what it is we're trying to do here, is when we do a scatter plot, we're going to have points all over the place. And it doesn't make any sense. We're not doing a connect the dot type of problem. So connecting the dots like that don't do me any good, because I can't model that. And when I talk about modeling it, I mean I can't write an equation for it. So what we want to do is we want to come up with a line that is about as close as possible to representing the data points that we have. And that's what our line of best fit is called. So it is the line that is closest to the data points. Now, we're going to do this by hand. Next year, you do it on the calculator, which is obviously a lot more accurate. Okay? Interpolation, inter meaning within, is using the line of best fit equation, because what we're going to do is come up with the equation in the y equals mx plus b form to approximate the value between the data set values. And you'll see examples of this when we move on. Okay? Extrapolation, the extra meaning outside, is we're going to using the line of best fit equation to approximate a value outside the data set values. Okay? Now, determining the line of best fit is a little bit tricky, and quite honestly, people can come up with slightly different lines of best fit. But what it is a straight line, and luckily these are all the notes we have today, that best represents the data on a scatter plot. Okay? It is a good fit if there are about the same number of data points above and below the line. And then finally, it's helpful to have 2 points on the line. All right, let's get out of the notes and let's get into an example. Okay, so the example that we're going to do a scatter plot on is the relationship between the number of grams and the number of calories in fast food. All right, so I'm going to skip the table, which you can have in front of you, and we're going to go to graphing this. So grams are the amount of fat is the x-axis, calories is the y. As we did with the height and weight yesterday, now the grams go from 3, or actually 5, up to, I think, a high of 34. So we can set this up to count by threes. 3, 6, 9, 12, 15, 18, 21. And I think I started the count wrong. 30, 33, 36. It's late in the day. This is my second video. 39. Okay. Now on the calorie side, I'm going from, I think, a low of 260 to 590. So I got to have my little break here. And I'm going to count by 50s because that'll get me there. Okay. Now I'm going to plot my data points. So my data points are 9 to 60, right around there. 13 and 320, right around there. 21 and 420, right around there. 30 and 530. 31 and 560. 31 and 550, so they're really close there. 34 and 590. 25 and 500. 28 and 560. Right around there. And 2440. It's a little higher than that one. And then finally 5 and 300. Okay. All right. Now, what I want to try to do is to come up with the line that best represents this data. Okay. And what I want to try to do is have as many points that are on both sides of my line of best fit. Okay. So what we're going to do is, if you look at it, I have, I think it is 1, 2, 3, 4, 5, 6, 7, 8, 11 data points. And again, nothing is perfect on this. But what I kind of called out is that if I went through the data point 5, 300, and 20, 440, okay, somewhere around right here, something like that. Now, this is unfortunately not the greatest because I'm drawing freehand. I've got a pretty good representation of dots, of data points on each side, okay? Now, how do I determine the line of best fit? Well, what I did is I made sure my line went through these 2 points, because now what that allows me to do is to determine my slope. So when I do this math, I get 140 over 15, or 9.3. And then I can approximate my y-intercept, which looks at around 250. But now I could just go in and put y equals 9.3x plus b. I take one of my 2 data points. So I'm going to put the 300 in for y and 5 in for x. And then I figure out that b is 253.5, so that I come up with my line of best fit of y equals 9.3x plus 253.5. Okay. All right. Now, like I said, people can have a little bit different line of best fit, but as long as you get it going through two data points and a good number on each, relatively equal number on each side, then you're fine. All right. Now I have test scores and time studied. All right. So, and let me orient this because my orientation gets thrown off pretty easily. So, sorry you have to wait a second. But so, my time studied is going to be my x-axis, and my scores are going to be on my y-axis. My time study goes from 1 to 6, so it's pretty easy for me to just count, okay? 1, 2, 3, 4, 5, 6. I can spread them out. My test scores, I can count by 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now I'm going to plot each one. 150, 2, 60, 3, 66, 3, 70, 3.5, 72, 480, 490, 4.5, 75, 4.5, 89, 588, 5.5, 91, 5.5, 100, 6, 93, and 6, 100. Okay? Now, if you take a look there, what I came up with as a line of best fit was a line that went through 1 and 50 and 6 and 100, something along these lines. I may be off. I'm pretty good. All right. And the way you would do this, you obviously wouldn't do this by freehand. You would do it with a straight edge ruler where you can see that you have an equal number of points on each side. So now, since I went through 150 and 6 100, I can now find that my slope is 100 minus 50 over 6 minus 1, or 10. Okay. I can then figure out that y equals 10x plus b, put 5 in for 1, 1 in for the x, to find that b is 40, so that y equals 10x plus 40. Now, what does my slope and y-intercept tell me? If someone studied 0 hours, they'd get a 40, and every hour studied increases your grade 10 points, okay? Because it's 10 over 1. 10 is your change in y, which is your score. 1 is your hour studied. Now, if somebody studied 2.5 hours, what would you expect? Well, you put 2.5 in, and you'd get a 65. This is an example of interpolation because the 2.5 is inside my data set. Okay? So what we did today was an example of using a line of best fit to help us figure out how we can now do uh, some sort of uh, interpolation, extrapolation, find stuff out about our data. No, we don't want that. Done. And we are